that you are going to take a class. Have you that you need to know to teach math? In other words, this textbook that you're using, oh, you don't have a textbook.
Yeah.
Can you sit next to somebody who has one?
Scoochie.
Just pull that table over.
Okay. Also, yeah, let's do it.
Let's just pull that table. You pick your coffee up.
I'm hoping. Ooh, yeah. I'm hoping to get one today.
Okay. Because there should be somebody from last semester who would have one
Yeah. That's what I
that
was
they're not using,
thinking.
and they would either loan it to you or sell it to you.
Yeah.
Okay. So now you can look on with somebody for page 514, exercise 8.1. And Carissa, you like that? Carissa and Charissa. Carissa is looking like, well, wait a minute. We finished up in Math 1 with chapter 6, and now he's jumping over to chapter 8. And I know I'm skipping chapter 7, and I wish we could cover it, but it's not as essential in terms of math content that you need to know as a math teacher in elementary. So I'm covering the stuff because this class is only 2 hours. If this class was 3 hours, we would learn a lot more math in here. Well, instead of 2 days a week, we'd meet 3 days a week, so we would cover 1/3 more math topics. You like the math? So but it's only 2 hours because the education department mandated that it only be 2 hours. I said, there's really 3 hours worth of math. They go, we don't care. They only have to have 5 hours of math content for certification. So let's just make this class 2 hours. So that's why it meets on Tuesday and Thursday. And I get to do math 5 days a week. Is that cool? I get to wake up every morning of the week and come over here and do math. Life doesn't get any better than that. So we're going to chapter 8 because you're going to need chapter 8. And what you probably ought to do before you come to class each time is read like 8.1, starts on page 504, and read up to page 514. I should have sent you an email, but if I would have, Charissa would have been stressed out because she didn't have a book.
You're right.
So there's no sense adding stress upon stress. So now you guys can go read that material, and you'll find when you read that material that if you've read it before you get here, the stuff we do in class registers more quickly and makes more sense. Even if you don't understand it when you're reading it. There's something about reading this stuff that when you've read it, even if you don't completely comprehend it, your mind is trying to wrap itself around it, and you get frustrated because you say, I don't even understand all the stuff I was reading. But when you come to class and then we start talking about it, then you go, oh, that makes sense. Oh, that makes sense. And I don't know if there's any way you could get the kids in your elementary math classes to read their math books before they come to math class. If you can figure out a way to make that happen, you will raise the bar. You will raise the level of their mathematical performance substantially. But I don't know what you can do to get that to happen. But if you would have read this stuff in advance, on page 509, you would have said, were all of you in Ed Psych? You weren't, just the two of you. Well, they've been in Ed Psych, so they've seen this before. And I'll give the little one to the person who didn't have a textbook and reward the other two with big ones. But if you were in Ed Psych and you would have read the pages before you got here, when you got to page 509, would you have said, uh-oh, Dr. Bonine's going to bring protractors and triangles to class? Do you girls remember in Ed Psych when I brought protractors and triangles to class? You should have seen the reaction I got from them. Celeste, when I walked into class and I passed out this math stuff, and here's what I said. Okay, take your little triangle and take your protractor and measure the angles of the triangle. And then write it down on a piece of paper.
We didn't know how to do that.
They got mad at me.
We did.
They got mad at me.
We didn't know to go.
And here, you could tell it by the look on their face. Here's what they're thinking. This is educational psychology. Why does he have to bring math to this class? Math is not our favorite thing to do, and he's messing with us in Ed Psych with math. But the guy who wrote the textbook was using math for an example. So measure the angles on that triangle with that protractor. And what did Charissa just say? We didn't know how to do it. So if you need some help figuring out how to do it, then guess what you can do, Celeste? You can ask Carissa. You can ask Carissa to show you how to do it. And then write down the measures of the angles on a piece of paper and then add them up.
Yeah, I got it.
What?
You got it exactly?
It came out to 180.
Oh, man. Now, see what's cool about that? Okay,
This is degrees.
I guess we could say this, Charissa,
Yes, sir.
that this is the second time you've done this in life.
Yeah, because we didn't use real.
Because you never did stuff like
We
this
would just
earlier.
put it on our paper.
So you just put it on your paper and did things. You didn't have real triangles to measure.
No.
Okay, so that's the first time she did that. She could not get them to add up to 180.
Actually, I did.
You did the first time? Oh, well, some of them, some people in the class
there were some
never
people
got
who
them to add up to 180, and that just made the matter worse. That just made them more angry with me for bringing that stuff to class.
Mm-hmm.
And you understand, when you give kids these tools, and then you give them something to measure, to use them, you're thinking, this is going to be kind of a fun exercise. But if it comes up to 180, it's a fun exercise. If it doesn't come up to 180, then you have to measure again. And somebody measured like 3 or 4 times, and it came up to 181 every time. Who was that?
I don't remember.
Could have been you. It might have been Kayla. I don't know. I know we both struggled.
But it's like, how could that happen? But if you measure the angles, and if one of them is 23, it's right between 23 and 24, so you call it 23 and a half. Then another one is between 46 and 47, so you call it 46 and a half. Or if you round it up to 47, and if you round the other one up to 26 or 27, round it up to 27, when you add those 3 up, you have 1 extra angle in there. So it depends on how you round when the lines don't come out right on one of those degrees. That's why I gave you protractors with real fine measurements on it, so you could be more accurate in measuring. So did it add up? So that's to 180? 109. So try it again and see what happens. That's okay. It's okay. Because and by the way, I think this is why a lot of elementary school teachers don't bring stuff like this to class. They don't know how to do it. So they don't want to be embarrassed by teaching the kids how to do it. Or maybe they just don't realize that it's valuable for kids to have hands-on experience. And this protractor, all it is a little measuring tool. It's a little tool for measuring things, for measuring angles. And I think once the kids touch protractors and work with them, they have a whole new appreciation for how angles are measured when they touch those kind of tools. Well, Is it working, Celeste?
We'll see.
Let's see what happens this time.
I want to tell you something. So you know your granddaughter Alicia,
Uh-huh.
and how she's a teacher, and I substituted for her on Monday and Tuesday.
Oh, you did?
Yeah, and so we were going through symmetry in math. So she gave us these, those papers that have all the squares, and you're supposed to just draw the opposite side.
Mm-hmm.
And I cannot draw for the life of me, so I was just sitting there like looking at that, like, how are we gonna do this? I don't know how to do this. So I was like, well, maybe if I fold it in half and then somehow use the light. And so I was trying really hard, and I kind of got like a rough sketch of it. I hand out the pages to the kids, and of course they're all like, we don't know how to do this, we don't know. And I was like, well, I tried to fold it in half and do it that way, so maybe try and do that. And this one kid holds it up to the window. He was like, look, you can look at it through the window and then draw it. So they all run over to the window and started doing it. It was so
See,
cute.
and I
We
really
figured
think
it out.
that, and that's where, and once you've had a lesson on symmetry, and you've done something like that, then they've got it fixed in their head, what symmetry means and what it's all about. And I don't know why. Well, maybe this is why. Look, I came to class at 7:30 this morning, dragging all of my stuff out here that I'm going to need for topic 8.1. And if a teacher doesn't have a closet to store stuff in, can you see where you can take up a lot of space having all this stuff that you need? And I had to put it up here on a little table so the people online can see it. And then we don't have anybody online. But I have to tape it anyway. So, okay, so now we've done this protractor thing. And here's another reason why some people don't do the protractor stuff. Because it takes time. What, we started at 8 o'clock and now it's 8:15. We took time doing this. And here's what some teachers will say. We took all that time messing with these protractors. Did you get 180 this time? We took all that time messing with protractors when we could have been covering more math material. And I go, yeah, that's true. But did you just cover the material or did you teach the material? You know what I mean? Did we just run over the material or did your students catch what was going on? Do they have a grasp of that mathematical concept? And some teachers will say, well, who cares as long as we cover the material? And that might be true in reading for history and social studies and things, but for math, it's a matter of helping kids understand. And the longer students go through life in school without understanding math, the more they dislike math. And the more you understand math, I think we could ask Carissa this, the more you understand math from last semester, the less offensive math is to you. The more that it makes sense, the less of a bad taste or feeling you have for mathematics. Is that fair to say that? Mm-hmm. That when we covered topics that you hadn't been, that your teachers had failed to help you understand it, and you saw it, you go, oh, well, that's not as bad as I thought it was. And hopefully having experiences like that, even in this class, with math content will help you register. When I'm helping kids with math content, I need to be realistic about their frustration levels and about the ones that I have. If I have them in 4th or 5th grade, then that means if the teachers in 1st, 2nd, 3rd didn't do the job, then we've got all this making up to do. But in math last semester, I'll just tell you guys, since you're going to be teachers, I had people in there who had been robbed of a math education all the way through grade school and high school. And they were so anxious about that class, and I said, you know what? Just relax. If you read the page before you come to class, and if you do the homework, you will pass the course. And they did. And one of them said to me, after class was over, I have learned more math in this class this semester than I have in my entire life, because no one ever taught me this stuff. And I was sure I was going to fail, because they knew they didn't have the math background. And here's what I'm telling you. If people come to you with what I call a math deficit, okay, a 5th grader can very quickly learn what he didn't learn in 2nd and 3rd grade because he's older and his mind works better. So when I'm working with adult learners or young adult learners on a college level, when I'm teaching math concepts that when I'm teaching math and they should have known all this from someone before but no one taught it to them, I know that they can learn that very quickly and we can make up for a whole bunch of lost time in just a little bit of time. Now there's a lot of math people that don't think that can be done, but I've seen it happen over and over again. And it happened in 2 people's lives last semester, and those people both passed the course and they have a whole new lease on life because they've taken an area of life where they knew someone had, can I just use the word, crippled them by not teaching them the math they should have taught them, and now they've just overcome that and they are on their way and they have it's just like, wow, if I can do this, I can probably do about anything. Okay, so if you haven't read these pages yet, go back and read them. And even if you read them after we talk about the exercises, after we do the even ones, because the way this class works is we just work the even problems on page 514 and 515 and 516. You do the odd ones for homework. And then you go to the back of the book and grade them. And if you missed them and can't figure out why, you can come here. Well, you can come to this class before class starts. I'm usually here every day at 7:30 and get some help. Or you can stay after class because this class ends at about 9 o'clock and your next class doesn't start till 9:30, and get your questions answered. So let's start on page 514 and just run through this stuff real fast. In problems 1 and 2, draw a line or a portion of a line that corresponds to each symbol. Exercise 2. Can anyone read what 2A says? If you can't, look back at page 505. And what does 2A? Can you read 2A? What does 2A say?
Half line PQ.
Look at page 505 and what does it say that is?
Wouldn't it be a half a line?
Half line.
And we have to draw the line?
Half line PQ. Why is it called a half line?
You just draw it.
Well, here's P. Here's a point P. Here's a point Q. And what does it say? Put a circle here and go this direction through Q and keep going to infinity. And if you went to infinity this way without including P, now what's this? If you went to infinity the other way without including P, the 2 lines would be each of them half of the whole line. Okay? So what's the next thing up there? Now they changed it to, they filled in the dot and said what? QP. So, look at page 505. How do you read that?
The second one?
What?
Did you say the second one? B?
QP?
Uh-huh.
Yes,
That's
2B.
Ray? QB?
See this filled in dot?
Uh-huh.
Then you say Ray, QP. And you go, what is that? Here's a point Q. Here's a point P. And it starts here at Q, so I fill it in, and it goes this direction through P on to infinity. And that's why it's called a ray. It's not a half line because we've included Q. So that makes it a ray. Technical. I know. That's just the way this stuff works. So what's 2C? What does 2C say?
Is
PQ. And what's page 205 say how you read that?
Okay.
505, is that what it is? Yeah, page 505. What's it say?
Line.
Line
PQ.
PQ. You follow this? Have you had geometry anywhere in life?
Yeah, it's been a while.
Have you all had geometry? So do all of you remember this from geometry?
Kind of.
You do? I'm impressed that you remember it. Then that means I don't have to. Okay, so problems 3 through 14. Do I even need to talk about those? Look at problems 3 through 14 and let's see if it makes sense. Then why am I doing this stuff if it makes sense to you? Oh, because I'm teaching you. Oh, I'm doing two things in here. I'm teaching you math, but I'm teaching you how to teach math too. Tell the little kids where to find the information they need to know. Don't just say it out loud. Let them read it in the book. So let's do 3 through 14. And it's A, B, C, D. Here's this big line. A, B, C, D. All right? Let's do it number 4. Does it say AC intersect? Number 4, AC intersect BC. And it says, now, am I copying it down right? Ray AC intersects ray BC. Did I copy it down right? Okay, now watch how you show your work. Because I've told you in the assignments to show you work when you do your homework.
Yeah.
Okay, where's ray AC? That's right here.
Wait, what problem are you doing?
4. Number 4.
Number
But
four.
but BC is a line segment, not a ray thing.
Number 4.
Yeah.
BC is line segment.
Oh, BC.
It's so little.
BC is one of these. Anyone know how to read that?
Line segment.
Right.
Line segment. Okay, good. You've got that. So line segment. So make sure I copy them down right. So now here's AC. Ray AC is like this. That's ray AC. And line segment BC. There's line segment BC. Everybody follow that?
Yeah.
Now, where are those two? What does that mean?
Intersect.
Intersect. What points, let me change colors here. What points do these two have in common?
Those.
And what would be the answer? AC, ray AC intersect line segment BC would equal what?
Line segment BC.
Line segment BC.
What if it's just one dot intersects? What would you write?
To infinity, right? You do the first point and then infinity.
Like if this was here, if that was open,
No.
No.
If
is
say
there
if
one?
it
Is there
was-
one like what you're thinking about there?
Yeah. 3.
3. AB.
Well, in number 3, they still just intersect.
Okay, let's just draw it up here.
No. Because
Let's do 3. Let's do 3 on the board.
Oh.
Let's do 3 on the board. What's the first one?
The ray AB.
Ray AB or okay, ray AB would be here and go in this direction.
Would it go all the way?
That's what ray means. It starts at A, goes through B, and
Well,
goes
why
to
does
infinity.
why doesn't it say AC or AD? Why does it have to confuse us?
It doesn't have to be, but ray AB and ray AC and ray AD are all the same thing.
Oh, okay.
So now there's ray AB. What's the next one? For 3.
Line segment BC.
Line segment BC. And where do they, is it intersection or union?
Intersection.
Intersection. And where do they intersect?
BC.
At
Line segment.
line
BC.
segment BC. Okay? Now, that's probably what we should do. Look over 3 through 14, and are there any of them that look confusing to you? In other words, I don't care if it's odd or even. if you've had geometry and you remember some stuff from it, do you understand? Or do you want to work a union one?
Yeah, union one.
Let's do number 6 then. AD, union CB. AD, union, what did it say? AD union CB. And here it says ray CB. And what's it say for AD for number 6? Line segment AD. So I come up here on my line and I put line segment AD that starts here and goes over to here. Everybody follow that? That's line segment AD. Now, and then I put CB, ray. So I start here at C and I go through B to infinity. And that's ray CB. And union says put them together. So if I put all of this with all of this, what would it be? It would start here at D and go where? It would start at D and go, since I'm putting them both together, and go through C, and it would be a ray, wouldn't it? See why you draw a picture of it to see what it's going to be when you put them both together? What would be the union of these two? The intersection would be line segment AC.
Okay. Yeah.
The union would be ray DC. Okay? Well, I think we've done enough of those, haven't we? Number 16, the figure below is a pyramid with a square base. I have one of those. Now, this is my Cadillac pyramid with a square base. See that? This is what you'll usually have for a pyramid with a square base. But I just had some colored paper. I thought, whoa, make a big one. Now, what are we supposed to do? Name all the edges of the pyramid. How many edges are there? You know what we mean by edges? Look up here. This is an edge, this is an edge, this is an edge, this is an edge, this is one, this is one, this is one, this is one. How many edges are there? And can you look at the picture on page 514 and name all the edges?
No.
I mean, I can.
What?
I don't wanna. A B B C C D A D A E B E C E D E.
Good. Now, do you understand why the little lines in the back are dotted? They're trying to show 3 dimensions on a flat surface. And I personally think when you teach this stuff to little kids, they're not going to get it by looking at pictures in 3 dimension. You have to bring little models to class like that for them to look at. And the interesting thing is when they look at the model and go back and look at the picture, now the picture makes sense. Is that cool? All right, so now let's move on. Okay, now can you answer the rest of the questions for 16? Which pairs of edges determine parallel lines? You know what parallel lines are, don't you? They're lines that don't intersect. So all of these upright edges intersect, so they're not parallel. Are there any parallel lines here? These, top and bottom, parallel, 2 sides are parallel. So you look at the picture and give names for those. All right, what's the next thing it says?
Does a pyramid with a triangular base have any parallel lines?
Well, I happen to have one here.
No.
What do you say? No. And isn't that cool? That, see, as soon as you ask that, if I have one to look at, as soon as you look at it, you go, no parallel lines for that one. And then what's the next one? Which ones are skew lines? You know what skew lines are?
Lines that intersect?
Lines that do not intersect and are not parallel. Ooh. Okay, that's why they're called skew. Ooh. lines that are not parallel and do not intersect are U lines. No, they're skew lines. So which lines are not parallel and do not intersect? Okay, watch this. Look up here at my picture, my little model. Here's a line going through here. Is there another line formed by one of these edges? I'll hold this up like this to represent the line. Here's a line going through here. Is there another line going through one of these edges that is not parallel but does not intersect this line?
The one on the back.
This one on the back
The other one.
is a skew line. You follow that?
Oh,
But all the rest of them intersect with it, don't they? Or no, wait a minute. Nope, that one's parallel, isn't it? So it's not skew.
Mm-hmm.
So with that one. So with both.
the other one on the back.
Oh, and there's another one, both of them. And this one on the back is skew too, isn't it?
Yeah.
Okay, so you see what they mean by skew lines?
Yeah.
You see how the model helps you figure it out? Then why wouldn't everybody do that?
Does this one have skew lines too then?
Oh yeah.
Because it's like,
Yeah, let's hold it up and check it out. Let's see. Here's this edge. Is there a line here that doesn't intersect with this?
mm-hmm.
Yep, right back there.
Okay.
That one. All right. Which lines are intersecting? And that would be all the ones that join somewhere. So just like this line here intersects with both of these. You see that? This line intersects with both of these. And it intersects with what? All these other three going around the outside too. Intersects with all of them. Oh man. Okay, number 18. Given any line M, so let's see if we can get a line M here. Celeste, would you get a hold of this? And Charissa, would you hold that? Okay, now here's the line M. And on the end of that stick is a little green thing called point P. Don't put it where it touches. Look what it says in the book for number 18. Given a line M and any point P not on M, there is exactly one plane that contains P.
And it's parallel.
Okay, you got to hold P still. You can't be moving it around.
There.
There you go. It'll quit vibrating in a minute.
Here, what if I put it?
All right.
There we go.
So now, here's this line. How many planes are parallel to this line? Okay, I could have a whole, see how this plane is parallel? Because a line through this plane is parallel to this line. But you see how many planes I could have around here that would have a line in them that's parallel to that line? Now, let's come over a little closer. There's exactly one plane that contains point P. There's one. Read what it says again.
There is exactly one plane that contains P and is parallel to M.
Okay, here's a plane that's parallel to the line and it contains P. You with me?
Mm-hmm.
Yeah.
Now, here's another plane that contains P and is parallel to my line. Agreed?
Mm-hmm.
I mean, I could have a whole bunch of planes that contain P as long as P touches the plane. You know, it wasn't your
had
fault.
one
I knocked
job.
it off. So what's the answer to that question? True or false?
True.
False.
Oh.
Because there isn't exactly.
Because there's not exactly one, there's
But
more
if
than
it
one.
said it was a line, then it would be true. Right?
A line parallel?
Let's see.
A line, one line parallel.
There's exactly one line that contains P and is parallel to M. Well, I don't know. Let's see. Let's see. How are we going to hold this up? That didn't work. I got to find a better way to do that one. Maybe if I do it this way, it'll work. Did that work? There. Yeah, that's going to work, I think. Okay. So you hold that one, and you stand this up on edge again. And there's only one line that contains P that's parallel to that line. Okay, this line's parallel, isn't it?
To M?
To M? Is this line parallel to M?
Not quite.
But could it be if I hold it just right?
Probably, yeah.
Now, would this line be parallel to M? No? If this line, it wouldn't be parallel, would it? To be parallel, it'd have to be the same distance. So it looks like what? There's only one line, but there's a whole bunch of planes.
Okay.
Why are you even asking that question? So that's why you keep asking all these strange
So
questions.
smart.
Oh, I know why she's asking those questions. Because those are the
Yeah.
odd ones, right?
Smart.
Yeah.
So she's going, how do you work the odd ones?
I don't
And-
care how to do the even ones.
So it's just like, okay, try to work the odd ones. And if you get stumped, then bring them back to class with you. Okay, angles. Problems 27 to 40. What's problems 27 to 40 look like? Well, it looks like, see this picture here? Let me put it up here and see if we can duplicate it. A line, and then what? Another line, and then two more. Up like this, and up like this. And it's got a little red thing here.
What problem is this?
This is problems 27 to 40. 27 to 40 are all using this picture. And it's A, B, C, D, E, F. Is that right? And it's alpha and beta. Did I label it right? No, did it backwards. Given a choice. Beta and alpha. Now we can answer the questions. Now that we have the picture. Name the following angles in another way. Angle C. Watch how you look at an angle. How do you read an angle? Angle CAB. What's another name for angle CAB?
BAC.
Angle alpha.
Alpha.
Oh, that's what it is.
It means alpha.
Okay? Number 32. Name an angle that is the complement of angle alpha. Here's angle alpha. Let me change colors here. Here's angle alpha. And I want the complement. The complement of alpha. You know what complement is?
No idea.
Well, what page is that on? Page 513. See why it would have helped to have read the pages before, but I didn't tell you to do that, so it's not your fault. What's the complement? The complement of alpha of angle alpha is what?
Is it the angle that'll make it equal 100, or not 100, but like the whole angle?
Which whole angle? This whole angle or this whole angle?
I don't.
Oh.
Which whole angle are we talking about?
Maybe the 90 degree.
The complement is for the whole 90-degree angle, where this little red thing. Guess what it would be if it was the whole thing around to the straight line? Supplement.
Oh.
Supplement. So what's the complement to angle? So the complement to angle A is right here.
CAD.
So how do you name that? What angle is that?
Angle CAD.
Angle what?
CAD or DAC.
What?
Which way do you do it?
What angle is that? I just didn't hear you.
Oh, DAC.
Angle DAC. What's another way to say it?
CAD.
Angle CAD. Everybody see that?
CAD.
It can be named either way. Can it be named ADC?
No, that would
No.
make sense.
You have to keep the vertex of the angle in the middle. All right. So do you see what you do? You just work down to there, and then now, and you could do 34 because you know what supplement means. What would be the supplement of angle alpha?
FAC.
It would start here and go all the way around to here. What would that be called?
Angle FAC.
Angle FAC, or what? Angle
CAF.
CAF. There you go. Well, we got that one done. Number 39, no, number 40. Number 40, if alpha is 15 degrees, all right. So alpha is 15. And what's it say next for number 40? So these go clear up to number 40. And beta is 55 degrees. What's the measure of CAE? CAE. What's the measure of that angle? How would you know? How would you figure it out?
Would you add it?
What happens if I put all three of these together? What does it add up to? 180. 90 here, adds up to 180. So what would that have to be? If this is 55, and this is 15, and then I add, what is that? The measure of angle, what? CAE. This plus this plus this equals 180. You see that? Add all three together. So what would this have to be? Well, what's 55 and 180? 70, subtract 70, and what do you get?
110.
So what does this angle measure?
110.
110 degrees. You got it?
Yep.
Problems 41 to 48 refer to the two intersecting lines. So now we erase all this. Do you see how when you're working these problems, you know why you need to take that piece of paper and draw the picture that's in the book on your paper? It fixes in your mind what you're dealing with. So I've got two lines that intersect. And what's it say about them? This one is 70 degrees, right? And what else does it say? And then this one is A, B, C, and this one is D. Is that what they're telling us? And then these are intersecting lines, so you have to put arrows on them, but that's just a technicality. So now, question 42. Name two angles that are supplementary to the 70-degree angle. What does supplementary mean?
The angle that will make it equal 180 degrees.
So I take this and go around to here. That would be one of them. Or I could take this. Okay, what would be the angle that would be a supplement to angle D? Angle A. Agreed?
Mm-hmm.
Or I could start here and go around to here, to this straight line. And that would make angle what? C would be a supplement to angle D.
What about a vertical angle? What's that?
Vertical angles are not supplements. What do you think? If this is 70,
it's
what's this one?
70.
Yeah. And they're going to
What
ask that
about
question too.
A compliment. What was a complimentary one again?
Complement. Now we don't have any right angles here, but if I wanted the complement,
It would be.
the complement of angle D, what is angle D? 70. The complement would be what you add to it to get what? 90.
Okay.
So the complement of angle D would be
740.
20,
Yeah.
20 degrees. Everybody see that?
Yeah.
And that doesn't have anything to do with the picture. That's just answering your question. You girls have all these questions that have nothing to do with the problems. Or no, was that one of the problems? I keep forgetting
What is the
that you girls like math so much that you look at while I'm doing the even problems, you look at the odd ones to see if you can get your homework done while I'm talking about it. And that's okay, so long as you can listen to what I'm doing and do that at the same time. Okay, problems 49 to 51. Man, 49 to 51. Use these two parallel lines with this transversal. Have you studied those someplace before? Parallel lines with a transversal. Oops, I drew my transversal the wrong way. Go figure. Two parallel lines and a transversal. And what does it tell me about it? It says this is 30 degrees. Is that all? Then it goes A, B, C, D, E, F, G. What did it do? Oh yeah, A, B, C, D, E, F. Is that what it did?
Yep.
G. I label it right? So now 50. Find the measure of angle D. What's the measure of angle D?
30.
Well, if this is 30, what's this?
30.
30. If this is 30, what's this?
30.
30. If this is 30, what's this?
30.
So what you do is say, if they give me this, oh, if this is 30, then what's A? Supplementary, so what would A be?
150.
150. See what's going on? This vertical angle stuff? You go, yeah, but how'd you know that was 30? Well, is it pretty obvious if these lines are parallel that this angle and this angle are going to match? Now see, in geometry, they probably didn't help you. They probably didn't say, is this kind of obvious? And you go, yeah, it is. They probably said, just memorize the theorem. Just memorize the postulate that says alternate interior angles of parallel lines are equal in measure. And you memorized it and had no idea what you were saying. Because they just told you to memorize the rules instead of looking at it and thinking about it and figuring it out. Okay. '52 just has a cute little picture, and they want you to do some stuff with it. Let's move over here to 57 to 60. Use algebra. All right. Have you all had algebra? So let's just draw 58 up here. And it's got a red thing there. We all know what that red thing means, don't we?
90 degrees.
That's 90 degrees. Okay? See, that's where drawing the picture helps you see what's going on. And a line coming out like this. And this is 4x. And what's this one? 2x? Is that right? So now, what's this? This angle measures 4x. This angle measures 2x. What's 4x plus 2x equal? See that red box?
It would be 90.
So 4x, the measure of this plus the measure of this equals 90 degrees. Everybody agree?
Yes, sir.
You see that? What's 4x plus 2x?
6.
4 axes, 2 axes give you 6 axes. 6x is 90. So what would 1x be? right? 90 divided by 6.
Yeah.
So x would equal 15 degrees. So if this is 2x, what's the measure here? 2 times 15? If this is 4x, what's the measure here?
60.
Is that pretty obvious?
Yeah.
I mean,
So number 60. Now see, we have a new picture. And this time it's a straight line. With what? A line up like that?
Yeah.
Did I copy it right? Well, close. 8x minus 14. This one measures 8x minus 14. And what's the other one measure?
6x minus 2.
6x minus 2. And if I add those two together, 8x minus 14 plus 6x minus 2, it's going to equal what?
180.
180. So I go 8x and 6x is 14x, and minus 14 and minus 2 is minus 16 is 180. So I add 16 to both sides, and I get 14x equals 196. I divide by 14, and I get x equals what?
yeah, I can't do
56.
that.
14, is that right?
Oh, that's really my
It's
goodness.
14.
14.
Oh, wow, that's easy.
196 divided. So now if x is 14, then I come up here and I put 14 in place of x. And what's 8 times 14?
8 times
Where's your calculator? What's 8 times 14?
112.
112 plus, or 112 minus 14 would be
190. Wait, not 190. 98.
98. Yeah. This is 98 degrees. And what's 14 again? 6 times 14 is what? 84. Is that right?
Yep.
Yep.
And that's
82.
82. And do those two add up to 180?
Yes, sir.
Good.
You.
So we got it right.
Sure do.
Okay. Number 62. Through how many degrees does the hour hand of a clock move going from 12 to 7 o'clock? So here we are with our little clock. Here's 12 o'clock. And down here, here's 3, here's 6, here's 9. So 7 is about right here. So there's 7. How many degrees is that?
Well, it's over 180.
Well, yeah, we know from 12 to 6
It's 180.
is 180. And then how much from here to here? Well, there's 7, there's 8, and there's 9, and that's a right angle. So this must be 30, 30, 30. Agreed? So that would be 180 plus 30 would be 210 degrees. You like that?
Whoa. That's cool.
Isn't that cool? Because you don't have to use some mathematical formula. You just draw a picture and think about it.
But this is 2 back. But this is 2 back.
Oh.
Number 64. And you stop when you get to 65, but let's do number 64. I have a triangle over here, ABC. And what does it say for 64? B is 67, C is 105. B is 67 degrees, C is 105 degrees. 105. What's A? Well, whatever it is, the measure of A, the measure of angle A plus 67 plus 105 will equal, why 180?
Because a triangle always has.
Because the three measures of a triangle always add up to 180. We just did that with our protractors, didn't we? Do you see where some kids are going to look at that and go, that just doesn't seem right? That's why I get the protractors and the little triangles and say measure them, because I want students to get fixed in their heads. And you guys have seen it, well, 2 of you have seen it twice. Ed, Psych, and here. Celeste has only seen it once. Are you going to remember it, Celeste? If not, buy yourself a protractor. No, you know what? I don't like these things anyway. I don't like the color of them. I don't know why, but each of you gets a protractor.
Oh, thank you.
And go home and just make triangles and keep measuring them and keep measuring the angles until you have it fixed in your head. So, what do we have here? 105 and 67, that's, what is that, 7, 12, 172. So the measure of angle A plus 172 is 180. So minus 172, minus 172. So the measure of angle A is 18 degrees. Now to check it out, take your calculator, add 18, 67, and 105, and what do you get?
180.
180. Okay. Well, we're done. And we got done right on time.
What number of problem do you want us to stop at?
65. Stop at 65. And guess what? If you, Celeste, want me to work some of the odd ones now, we will sit here until you have to go to class at 9:30 and work odd ones.
Okay.
And I'll help you with your homework as long as we want to work on it. Or if you say, I'll try it on my own and get stumped, then I'll bring it back tomorrow and we can work on it. You probably don't want to come before class tomorrow, but we can stay after class tomorrow and work on it.
Okay.
It's your choice either way.
I'm gonna work on it by myself at first.
But if you get stumped, don't get frustrated. Isn't that right, Carissa? Or don't get frustrated. Just bring your question to class and he'll help you figure it out.
Okay. Thank you.
And when you figure it out, you will go, just like you said a while ago, oh, that's neat. Because guess what we're going to do in this class? We're going to have some, what's the word, Carissa? Fun. Did you hear that? She said we're going to have some fun in this class. Have a good day.
You too.